Hello, my name is Mohammed Siddiqui and my topic is smoking status detection. So the research question I am addressing today is how can we differentiate smoker from non-smoker through machine learning techniques. So why are we using this research question? The reason is, can we tell someone is smoker or not just by looking at their health info? This matters a lot because it can change how we look after everyone's health. If we know who smokes and we can help them better and maybe even stop smoking related sickness. This work can also help insurance companies figure out risks and make sure people are paying the right amount for their insurance. At last, it's just not about health and technology. It's good for society too, making sure we are all healthier and happier. Now, let's talk about dataset. The dataset I have chosen is from Kaggle. It is a smoking dataset which contains over 55,000 people data. We have got basic stuff like how old they are and whether they are male or female. Then it gets into more details like how tall they are, how much they weigh. But that's not all. We also look at their blood tests like cholesterol and sugar level too to check out their heart health and other stuff. Plus, we are checking out their kidney and liver health too. With this data, we are trying to solve for a question whether the person is smoker or not. So now let's talk about machine learning technique. We use a method called classification. It's like sorting things into buckets, smoker in one and non-smoker in another. Unlike guessing number of grouping things without clear labels, classification is perfect for yes or no questions. We have used four algorithms in our project. The first one is random forest. The next one is support vector machine. The third one is multi-layer perceptron, and the fourth one is decision tree. So let's discuss a bit more about our algorithm which we have used in our project. The first one being random forest. Think of as a group of friends working together. Each friend is like a detective, and they all look at a problem from different angle. Then they vote on the best solution. This helps us make better decisions, especially when our data is noisy. Next, we have support vector machine. Imagine it is a teacher who draws a line in a playground to separate students playing tag. This line maximizes the space between the two groups, making it easier to tell them apart. SVM help us distinguish between things like smoker and non-smoker in our project. Now let's talk about multi-layer perceptron. Picture it as a smart robot with layer of detector. It can spot tricky patterns in our data, like finding a lost treasure in a maze. MLP is a great for solving puzzle when we have a lot of clues. Lastly, we have the decision tree. Think of it as a roadmap with yes or no questions. You start at the top, answer question along the way, and end up at a destination. Like deciding what to wear based on the weather. Decision tree help us to understand decision making process easily. Now let's talk about our data analysis and result in our project. So in data analysis, first we handle missing values. Column with missing data such as waist, eyesight or hearing were checked and rows with missing values were removed. And then we check for duplicates. The data set was scanned for duplicate rows across all columns to ensure that each entry starting from ID to smoking represented a unique individual's data. Then we performed feature engineering. In this, the height and weight columns were removed and we added a new column BMI, which was basically the height versus weight ratio, providing a more comprehensive health metric. And the next one was encoding categorical variables. Categorical column like gender, oral, and tartar were encoded into numerical format so that the algorithm could process them. And then we performed data normalization. Numerical columns such as cholesterol, triglyceride, and blood pressure were normalized to have a consistent scale across the data set. And last we do the feature selection. Any column that did not contribute to the predictive power, for example ID, which is typically an identifier without predictive value, was removed from the feature set which is used for modeling. After performing all the four algorithms in our dataset, random forest was performing best. It gives us accuracy about 83%, whereas the algorithms such as SVM give the second best accuracy, which was 79%, following MLP, which gave us accuracy 77%, and at last decision tree, which gave us the lowest precision accuracy rate, which was around 75%. It did a pretty good job actually, random forest. When it guessed someone was non-smoker, it was right about 88% of the time, and for smoker, it was correct around 75% of the time. When you look at all the guesses it made, it was right 83% of the time, which is quite great. We also have this thing called a confusion matrix that basically shows the details. It's like a scoreboard. For the non-smoker, it got 6002 right, but it missed 1025 and thought they smoked, but when they didn't. For actual smoker, it correctly identified 3257, but it didn't spot 855 of them. This help us see where we are doing well and where we can improve. So overall, our program is on the right track. As in my project, I use different classifier like random forest and SVM to understand health related data better. Each classifier has its strength, and I learned to choose the right one depending on the data and what I wanted to achieve. A big part of my work was preparing the data, like filling missing values and turning words into numbers. This show me that having clean data is super important for accurate predictions. I also look at which factor were most important in deciding if someone smoke or not, especially with random forests. This could help with targeted programs. Uh, Lastly, I evaluated the model using things like confusion matrices to see how well worked, how they perform and work. I found out that each model has its quirks, and it's vital to test them thoroughly to make sure they do what they want and what we want. So let's talk about data limitation. Our data has some limitation, such as reporting issues and missing information. People might not always give correct information about whether they smoke or not. And also, we might not have all the details that explain why someone smokes, like how much money they make or how they are feeling. And our model is very hard to explain. Our complex model can make good guesses, but it's tricky for someone to explain. And it also changes quickly over time. For example, people cholesterol and blood pressure can change over time frequently. And also our data is very uneven, and also it has some made up issues. There may be way more people in one group like non-smoker than the other, which can make it harder for our model to learn about the smaller group, which is smokers. To fix this uneven data, we made some fake data points, but this could make the model too focus on this made up example instead of the real people's data.